Hi everyone, in today's video we're going to be looking at homologous series. So a homologous series is a group of compounds. It's a family of compounds. For example, alcohol is a homologous series, alkanes, alkenes, these are all homologous series that you've seen in IGCSE. They have the same general formula. For example, if you still remember, alkanes have general formula CnH2n plus 2. And the homologous series will have same chemical properties, which means that they will undergo same types of reactions. For example, alkanes, they will undergo reaction with chlorine or halogens in the presence of UV light. So all alkanes will undergo similar reactions. And across a homologous series, you will see a gradual change in physical properties. For example, you can see an increase in melting point or an increase in boiling point as the number of carbon atoms increases. You will also see a change in flammability. It can become more flammable, less likely, but the more likely trend is that it becomes less flammable as the number of carbon atoms increases. Now, organic compounds are grouped in these families. This is what we refer as homologous series, and each homologous series has a particular functional group. So the functional group is the reactive part of the homologous series, and these are a few of the homologous series that we'll study for this year. Alkanes actually don't have any particular functional group, so it's just that it's a saturated molecule, so no particular functional group. Alkenes, they have the functional group C double bond C. Alcohol have the functional group OH. Carboxylic acid have the functional group COOH, right? And usually these are the parts of the molecule that will take part in chemical reaction. This is what will determine what kind of chemical reactions the homologous series is going to undergo. Now, the number of carbon is going to help us to name the homologous series. So if it has one carbon, the name will start with meth. 2 carbon, it will start with F. 3 carbon, it will start with prop. 4 carbon, it will start with but. 5 carbon, it will start with pent. 6 carbon, it will start with hex. 7 carbon, it will start with hept. And 8 carbon, it will start with oct. 9, it will start with non, and 10 will start with dec. But your syllabus limits your nomenclature for up to 6 carbons. Okay. Now, how do you name organic compounds? So these are a few steps of naming organic compounds. So the first thing is for you to find the longest chain, and then you number the carbon atoms in the longest chain. So for example, let's take this one. So first we'll find the longest chain. So you have one chain here and you have one chain of carbon. When I'm talking about chain, it means chain of carbon. So you have 2 chains. So the longest chain is this one. Okay, so we are going to number the carbon atoms in the longest chain. So this is carbon 1, 2, 3, 4. So which means that the first part of the name will indicate the number of carbon in the longest chain. So the name is going to start with but. And then the second part of the name is going to show the homologous series. So if you look at this homologous series, this is an alkane. It has no double bond, no OH, no any group of atoms. So it's an alkane. So it will be butane. But how do we show this part of the molecule? So this chain contains 1 carbon. and because it is a chain, so it will be called methyl. Okay, so this is methyl butane, but we also need to indicate the position of the methyl butane, and that methyl butane, that methyl chain should have the lowest number possible. And when we are counting, we can count from this direction, so 1, 2, 3, 4, or we can also count from this direction, 1, 2, 3, 4. And if you count in this direction, so this would be carbon 1, this would be carbon 2, this would be 3, and this would be 4. So then the methyl is occupying the second carbon. So then it would be 2-methyl butane. Okay? Then here we have another example. So let's again count the carbons. So longest chain, 1, 2, 3, 4, 5. 5 carbons, therefore it will be named pent. Okay, it has an OH, therefore the end of the name should indicate that it's an alcohol. So pentanol. Okay, now the thing is that we have an OH and we also need to indicate the position of the OH. Okay, and the OH here is on the third carbon. So then the name would be penthreol. So that's the name of this alcohol. Okay, we'll be looking at more nomenclature guides as we're going along in the unit. But for now, to be able to name the homologous series, you have to know what they are. So alkane, no functional group, ends with ane, example butane. Alkene, you will see double bond, so it will end with ene, so propene. Alkyne, you will see triple bond, so it will end with ine, so example ethine. Arene, if you see a benzene ring and on that benzene ring you see something, for example methyl benzene looks like this. So you have the benzene ring and then you have CH3. Okay, so this is methyl benzene here. And alcohol, so it will end with anol, so propanol for example. Phenol, if you see that benzene ring with an OH and then let's say you have CH3 attached to it, so here it's going to be methyl phenol, right? Aldehydes, you will see C double bond OH, for example propanol, it ends with ANAL. And you have ketone, so C double bond O, and here you will have an R group. So you will have carbon on both sides. R means that it's a carbon chain. So for example, propanon, it will end with anon. Carboxylic acid, you're more familiar with this. So it will end with anoic acid, so propanoic acid. Ester, you will see COO. Okay, amine, it will end with NH2, so ethylamine. Nitrile, you will see CN in here, so propanonitrile. Amide, you will see the amide group, what you have seen in IGCSE as the amide linkage. Okay, so this table should be you're going to use this table regularly for your reference. You don't need to learn it by heart, but eventually as you're going to practice organic questions, you're going to eventually learn the table, but have it on your side for reference. So let's see a few examples. So this one has 3 carbons, so prop, alkane, so propane. This one has 4 carbons, so butane. This one has 2 carbons, so eth. It has carbon triple bond, so it's an alkyne, ends with ine, so this is ethine.